Welcome to the lesson on heights and distances. At the end of this lesson, you will be able to define the angle of elevation and the angle of depression. Can we determine the heights and distances of distant objects that cannot be measured directly? For example, the distance of an island from the ship, or the height of a lighthouse that is at a certain distance from a ship, or the height of a mountain, and the speed of a moving object. Yes, if we know some suitable angles and distances, we can apply trigonometry to find the required heights and distances. Let's learn more about this. We'll begin with a simple example. Here, a wildlife photographer is clicking photographs of seagulls. This particular seagull flying overhead has caught the photographer's fancy. Oh, it seems the seagull has spotted a prey. The seagull has suddenly changed its path of flight. Let's trace the path of the camera's view. Two lines are formed. These lines are called the line of sight. In the first instance, the seagull was flying overhead, and the camera was elevated upwards with respect to the horizontal line. While in the second instance, the camera was bent downwards with respect to the horizontal line. The angle which is formed by the line of sight, which is above the line of the observer's eye, is called the angle of elevation. And the angle formed by the line of sight, which is below the line of the observer's eye, is called the angle of depression. Now, let's consider another example. A jet plane is flying at an angle of 60 degrees from a point on ground level, which is horizontal line. After a flight of 15 seconds, the angle at which the plane is flying changes to 30 degrees. The jet plane is flying at a constant height of 1,800 meters. Given this information, can we find the speed of the jet plane? First, we'll draw a rough figure based on the problem. Here, A is the point of observation and AC is the horizontal line through the point of observation. P is the point at which the height of the plane is first observed, and Q is the position of the plane after 15 seconds. AP and AQ are the two lines of sight. PB and QC are the perpendicular distances of point P and Q respectively from the horizontal line AC. The angle PAB is the first angle of elevation, which is equal to 60 degrees, and the angle QAC is the second angle of elevation, which is equal to 30 degrees. PB is equal to 1,800 meters, which is the constant height of the jet plane. Let's assume that the speed of the jet plane is x meters per second. In triangle ABP, angle PAB, which is equal to 60 degrees. Applying trigonometry, we know that tan theta is equal to the opposite side to theta divided by the adjacent side to theta. Therefore, in triangle ABP, tan 60 degrees is equal to PB divided by AB. Recall that tan 60 degrees is equal to the square root of 3 and given PB is equal to 1,800. Substituting these values and simplifying, we get AB is equal to 600 root 3 meters. Similarly, in triangle ACQ, the angle QAC is equal to 30 degrees. We know that tan 30 degrees is equal to opposite side to 30 degrees divided by adjacent side to 30 degrees, that is QC upon AC, Let's substitute tan 30 degrees as 1 upon square root of 3 and QC as 1800, since QC and PB are equal as the jet plane is moving at a constant height. On simplifying, we get AC is equal to 1800 root 3 meters. From the figure, BC is equal to AC minus AB. Substituting the values of AC and AB and simplifying, we get BC is equal to 1200 root 3 meters. This is the distance travelled by the jet plane in 15 seconds. Recall that the speed is equal to the distance travelled divided by time taken. On substituting the corresponding values of distance and time in this formula, we get the speed as 1200 root 3 upon by 15. On further calculation, we get the speed as 138.56 meters per second. Therefore, the speed of the jet plane is 138.56 meters per second. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. Line of sight. The line joining the observer's eye and the object observed. Angle of elevation. The angle between the horizontal line and the line of sight which is above the observer's eye. Angle of depression. The angle between the horizontal line and the line of sight which is below the observer's eye.